that the solutions are going to be rational?
Probably not.
Yeah, because I know that's my b squared minus 4ac. It's definitely negative.
Yeah.
So I think I have to use quadratic formula, and I think it's going to generate. Is it 2 plus or minus? Is it just big?
Yes.
One yes. It's one. That means 2.
Yes.
3. Okay, that makes it nice even or nice odd primary. And I think for the non-homogeneous case, coming up with a trial particular solution is going to involve, I don't know, is that an a times e to the 2x times tangent of x?
No.
Because I just want to find a trial particular solution that looks like the forcing function with my method of undetermined coefficients. Chris?
When you differentiate that, it's going to mess everything up.
When I differentiate, it's certainly going to mess things up because I'm going to get secants, which I don't have. And I think besides, everything I said is wrong. When I use that method of undetermined coefficients to come up with a trial particular solution that kind of looks like what's in my forcing function's position, I only do it if the forcing function involves polynomials, exponentials, sines and or cosines, or maybe a combination thereof. So I think I failed in coming up with a technique for solving the homogeneous case. As a matter of fact, since it is the case that this forcing function is not one of my standard types that I just listed, I think I have to give up and use the only other technique I have for higher order DE, which is variation of parameters. I know I'm being silly. I know it's an section on variation of parameters, but treat it as like a test question. Yes, Chris?
Since we now know variation parameters, do we even need to use these?
Good point. It's just that when it comes to maybe a third order DE, it might be the case that it's a bit lengthy in terms of writing because you'd be solving 3x3 systems. So, good point. I agree. And I do think that with variation of parameters, my particular solution is going to look like a whole new dependent variable times my y1. Plus my u2, another whole second dependent variable, times the sine. Oops, I forgot my exponential factor. Hold it. I meant e to the 2x times the sine of x. That being the case, diving in, oh shoot, should I be looking for duplicity?
Yes, we should.
See, I don't think I should because, again, it's a different method. I'm not using method of undetermined coefficients. Besides that, even if some of these things that I generate for U1 and U2 really are similar to my complementary solution, I can just absorb them in if there is duplication. And I think I want to solve a system of equations. The system of equations I want to solve looks like this. My U1 prime times my Y1 plus my U2 prime times my Y2 equals 0. Because I know I'm writing too much. You probably wouldn't write this. The other equation involves my U1 prime times Y1 prime plus U2 prime times Y2 prime being set equal to, yeah, my f of x, my forcing function. Okay, you guys, I did waste some ink. Technically speaking, I know what Y1 is. I guess my system of equations looks like this. My second equation looks like this. Okay, you guys, I gotta slow down. I gotta slow down because differentiating this product means I gotta use the product rule. I'll walk a little slow. Does that give me is that a negative e to the 2x sine of x plus 2e to the 2x cosine of x? Plus my u2 prime times, well, here too, differentiating. Here's the first times the the second. You guys, I think I made a mistake. I think I'm missing a 2. My apologies. Here's my first times the second, plus my second times the first. And that's equal to my forcing function. Okay, guys, at this stage of the game, I'm tired. Do you mind if for every equation I write here on after, can I just drop e to the 2x on both sides? I'm just dividing by it. You know what, you guys? Maybe I should have just gotten rid of it before I dove into differentiation.
Yeah.
Would that be okay, though?
Because you
That's true, but notice through the differentiation product, I used a product rule, didn't I? Where if I didn't have it, I wouldn't be using the product rule. So I think it's only at this stage of the game, if I really choose to do such, divide out both sides by either 2x on both those equations. So it's safe. And to solve the system, I don't know, you guys are tired. I don't want to go through all the lengthy processes we have with matrices. Let's just cheat. Let me just solve for one in terms of the other from the first equation. If I solve, for example, how about for u2 prime? Doesn't it tell me u2 prime is nothing more than a negative, is that tangent of s? No, it's not. My apologies. I think it's cotangent. Jeepers. Now, if I pick this up off my inkboard, slap it in for u2 prime down in the second equation, I think it generates the following. That gives me my u1 prime times stuff. Ay, ay, ay. So negative sine x plus cosine x times 2. Plus my u2 prime times my cosine of x plus 2 times the sine of x. I'm just, at this stage of the game, going to replace u2 prime with u1 prime times that stuff. Thank goodness. At least now I got one equation I want to know. My one unknown being u1 prime. I just got to clean the mess up.
I think it should just be tangent x on the right.
It is, I forgot to divide it out by EBS, just 2x. You guys, anybody see fast tricks? Gosh, when I pull out the u1 prime, nothing cancels. Well, I suppose I get a bit of cancellation. Let's see, I don't know what I get. I can't read that far ahead. u1 prime times stuff. Let me distribute. This times this. How about this times this? Signs cancel. I got a negative 2 cosine x. Isn't that nice? Cancellation. I'm merely left with a negative sine of x minus a cosine squared of x over sine of x. Oh, come on, it's not that nice, is it?
Sorry, where did you get the cancellation? Okay.
When you pick this up, multiply here. Sines cancel. I get a negative 2 cosine. There's a positive one. Doesn't that just give me u1 prime times 1 over sine of x? That's negative. Come on, you guys bark at me. There's something wrong, we're just skipping too much. That being the case, I think I have my u1 prime of x being equal to, I don't know, you guys have to differentiate.
Sine squared over cosine would just be
So negative secant of x plus cosine of x. Fine.
For the step from, I guess, the u1 prime parentheses negative sign
Gotcha.
To the next step, how did you get rid of one term?
Now it's just over one denominator. But this whole thing in my blue circle is just 5 by Pythagorean identity. Right?
So when would it be appropriate to treat this as a green function, or one of Green's functions? Because I did that on a lot of the homework, and it seemed to work pretty nicely.
Did you really?
Yeah. Is it, I mean, is this just a different way of doing it? Because oftentimes the solutions manual would treat it as a Green's function, and you just find the Wronskian and plug it into the integral and find your YP that
I
way.
was hoping this wasn't going to come up. Here's the bottom line.
Okay.
I mean, in class, I derive Green's functions.
Yeah.
And you guys, when I come to class, I don't remember what Green's functions are. I just derive them out of thin air.
Okay.
I never use them myself. And once I derive them, I don't remember again. But you got to confess, I derive Green's functions just by applying this variation parameters technique in the general setting. So to answer your question, Green's functions will always give you the same answer. I'm get it here with variation parameters.
So it's perfectly fine to do it that way if it works better for us?
You can be pretty darn certain on the next exam. I will state that if you're going to solve such a system, solve such a DE, use variation parameters, not Green's functions.
Use variation parameters instead?
Yeah.
So
Okay.
you consider Green's cheating?
It's not that I consider it cheating. I just hate to have you guys be so formula driven. I want you to be process driven. I'm just memorizing a formula. Could you redrive Green's functions?
Probably not.
That's a good test question.
No, it wouldn't. That would be a bad test question.
You're
Don't-
making us memorize the annihilators, which is a formula.
That's true, but I think you can just check yourself in 15 seconds. That differential operator doesn't annihilate those functions.
Maybe 15 minutes.
15 minutes. Seconds, minutes, different time. Time's very full. You guys okay so far?
Yeah.
And do you guys agree? Mice a piece of cake. Sorry. Yes, Michael?
Could you quickly explain how you went from U prime to U? U prime 1 to U, like,
Yes, I just simply anti-differentiated secant and got my natural law.
okay, because in the book, it, when it goes through that process, it does some, like, weird thing where, like, they have an integral, but there's no lower bound, but it goes to an x, and then, they just say to make the,
Really?
yeah, like in problem 2 in the solution, it uses a weird integral.
Do you have them in front of you?
I don't
No.
have the actual answer.
They might be trying to show why it doesn't have a plus c, they're just saying maybe it's this integral at these bounds. That's
Oh.
maybe. Because if you just integrate that, you would get a plus c, but we know to leave it out because we're just looking for one. Okay, so maybe that's why they use bounds like that.
Now, I like the way you're saying things. You're saying, we're just looking for an antiderivative, so who cares about the C? But you know, you can look at it differently. The real reason why the C is not included is because if you did include it, so you guys watch me. If I did include it, I'd bring U1 prime back over here. I get some junk plus distribute in. I get C times the stuff plus other stuff. But C times the stuff just gets absorbed into the compromised solution. That's really the reason why it's completely unnecessary. I'll take a look at it, Michael. I can't imagine why people did that. I'll take a peek. The reason why I'm really puzzled by what you're saying is because I'm anti-differentiating. I really do want to come up with a function in the same variable. So that's why I'm perplexed. So what's the next number? I can't read. Number. Yeah, how about nothing? I'm not even done. So I found U1, I've got to now find
U2.
U2. So I'm going to come back in my lazy fashion, try not to do a lot of work. I'm going to stick it back into that relationship up there. Now I'm out of room on the board. So do you guys think I can come in and actually just rewrite it over here so I can use that space? So I think my particular solution is going to be that U1, which is the sine of x minus the natural log of nasty business. Did they give me limitations?
Yeah, the limitations are from 0 to pi halves.
Oh, you know what I get to do, you guys? I get to suppress the my absolute value loss. That's why I stall. And with those restrictions, it's never going to be negative.
So
I've got it.
how much are you actually going to want us to clean this up at the end? Because, I mean, even using Green's functions, it still looks a little scary once you get to the end of this. I mean,
It's just because we're close to Halloween.
yeah.
We'll further we get from Halloween out, the less scary it'll be.
But, I mean, like, how much do you want us to simplify at the end? As much as we
Truthfully,
can,
as
or
much as you
just,
can,
yeah. But, I mean, are you going to be really strict on that, or?
Yeah, I would on that.
Yeah.
I would on
Okay.
that. And I think picking that up off the board, slapping it back in up here, I think that implies my U2 prime is going to be equal to negative cosine over sine times my U1 prime, which I found to be what was a natural log of
Negative.
yeah, natural log of nothing. I'm gonna put back in my u1 prime here, which really is my cosine of x minus 1 over cosine. And that's gonna tell me, excuse me, my goodness, it's gonna tell me u2 prime. Okay, I don't know what I get. Is that a negative cosine squared over sine? Is that a plus 1 over sine?
Well, that's easy.
Yeah, it's not bad, is it?
Well, look, you can simplify right there. Oh, I'm sorry. Yo, yeah. Yeah, that's just a sine of x. Same-
Yeah, it is.
Same denominator, sine squared.
I agree. You were just faster than me.
Sweet.
Does everybody see it? Michael?
That comes from the relationship of 1 and sine squared plus cosine squared.
Yeah, or how about this? In the numerator, 1 minus cosine squared of x is just sine squared of x. Then we cancel factor sign. And I maintain that means u2 is, shoot, piece of cake. So u2 is,
Sweet.
that reminds me of something. Can I tell you just a small embarrassing personal story here?
Sure.
I worked in London for a few months. At the end, I was able to just take a whole week off and travel around. Right, 2 weeks. And went into Scotland, and an associate with this place I was working said, except for my wife with me, said, well, you guys can have my flat. Just show up in the evening, the flat's yours for the night, I'm taking off and heading out of town, and the whole place is yours, I'll be back the next morning. And she had this wonderful flat where one entire wall was glass from top to bottom, side to side, the entire wall, and it faced north. It was really cool. And so, and it got really late, and my wife was a real Anglophile. And she said, well, look out the window, you can see the lights, those are the northern lights. I'm told that you can see northern lights even as far south as Scotland. So really cool, really cool. So, you know, the next morning the woman came back and we told her that we saw the northern lights. And she kind of looked at us and she said, where? And we pointed in the direction. She said, oh no, that was just you two doing a concert in the park. These dopey Americans thought they saw the northern lights. Sorry, I'll come back. Putting things together, does that mean I have minus my e to the 2x sine of x, cosine of x? Now that's my final solution. Yeah, it's my final particular solution. And maybe not even final, check this out, Brad, going back to what you're saying. Distribute here, that cancels that term. So I think even for my particular solution, I think it'll look nicer as negative e to the 2x cosine x times the natural log of stuff. And then, of course, I'd add this to my complimentary solution. But my complimentary solution is just, you know, deep REM sleep is just, are you guys doing the homework?
It's C1.
It's E2x.
It, but, you already simplified it. C1.
Ay, ay, ay.
So the correct question would be, are you guys doing the homework and can you simplify it all in your head?
Not.
And
And then add those two together, you got your final solution. Man, you've got more to look at. So we're looking at 6.431. 6.431. I can't. There is no 6.431.
But I don't think, it might not have been 31 that I asked. Let me go good. It might be 6.3 because, yeah, it's 6.3. It's all 6.3. I keep looking at the top of the page and the
I know
first
this
part of
book is
6.4
awful,
starts
isn't
it.
it?
All the books do, it's the same thing. I have the same problem with them all.
I find this one worse than most.
Yeah, so 31, I have a giant question mark next to it, so that means it's probably bad. And there's a couple other ones. And this is Annihilators, right? Yes. After I annihilate something, I go, you're annihilated.
not use annihilators in determining your trial.
Yes, yes.
Well, I think my trial particular solution is going to look like this.
Yes.
Do you want me to say that again?
No.
Why not?
I have a feeling it has something to do with duplicity.
Thank you. Now, don't take this the wrong way, that might be correct, I really don't know. My point is, I need to go in and actually find a homogeneous solution first. I need to find the complementary solution first, because if there is duplicity, I gotta remove that duplicity. Did you guys see my point? So, walking too fast, I'll take a step back. I will take a quick peek at the homogeneous case. And to take a peek at it, I will simply list the characteristic equation. Oh, come on. That's not nice.
Swinging factors of a group.
It's very nice.
That's just too nice, isn't it?
Very nice.
Yeah, it cleans up really nice.
Oh, thank you. I didn't see that. So if I just got an r plus 3, times an r minus 2 times an r plus 2, that was very silly, wasn't it? So clearly no duplicity, my complementary solution is nothing more than a c1 e to the negative 3x plus c2 e to the 2x plus a c3 e to the negative 2x. That being the case, I'm okay with my trial particular solution when I dive into the non-homogeneous case. And differentiate it repeatedly. You guys, you know what? This one, if I can say this, is a lot of light work. Can we just do it?
And so, can you maybe take a second here just to explain why it's a cosine of x plus b cosine of
Is your
b sine of
question
x?
really why am I introducing a sign?
Well, I want to know why that's your particular solution there.
Because if I were to differentiate this function
Yeah.
repeatedly,
Yeah.
I get sines and cosines through the
Sines and
differentiation
cosines,
process. And
okay.
that's why my trial particular solution has to be in those general form of such a combination of functions.
Okay. Okay, that makes sense.
And differentiate it repeatedly. So on this one, can we use a differential technique?
Yeah.
And in picking up that collection of derivatives, slapping it back into the original non-homogeneous dE, I think this is what I get. I think I get my a sine of x minus my b cosine of x. Minus my 3a cosine x minus 3b sine x.
Plus. Minus, just minus, sorry.
Minus 3 and then plus 3b.
We're doing left and right.
So I was just multiplying by 3 here. And minus 4 times y prime, is that going to give me a plus 4a sine of x? Is that going to give me a minus 4b cosine x? And lastly, I've got a minus 12 times y, but that would give me a minus 12a cosine, minus 12b sine. And all of this is going to be equal to nothing more than 4 cosine of x. Now equating coefficients. For number 1, the cosine of x. Number 2, the sine of x. Let's see what happens. And if I were to equate coefficients of cosine of x, let me just underline negative b minus 3a plus 4a, if I said cosine, hold it, I meant minus 4b. And then minus 12a is equal to that coefficient of x. But in the end, you guys, doesn't that give me a negative 15a? Does that give me a minus 5b is equal to my 4? Now, equating the coefficients was not underlined the sine of x. I think that's gonna give me a certain number of a's, like 5 of them. I think it's gonna give me a certain number of b's, like negative 15 of them, being equal to 0. There's my system of equations. And if I, for example, multiply both sides of the second equation by 3, added to the first one, isn't that going to give me negative 50b, being equal to 4? So that b is nothing more than negative 4/5, or 4/50, excuse me. And I think just stealing the second relationship, now that I'm b, a is going to be a piece of cake. Because I think a is nothing more than 3 times b. Wow, you guys, poor representation. I didn't even simplify my fractions, did I? Jeepers. So I think my final solution is going to be nothing more. Then my y1, excuse me, c1 e to the negative 3x plus c2, as I recall, e to the 2x plus c3, I think e to the negative 2x plus my particular solution, which really looks like a minus 6/25 cosine of x minus 2/25 sine of x. So Brad, now that I've done this, I'm not quite sure where the problem came in.
The problem is really stupid, if I tell you what it is. All right, so I set it all up like that, but then I couldn't see equating coefficients, but then I noticed that you're just treating the cosine of x as, that's just what I wasn't doing, yeah.
It's because you're so used to solving for x.
So used to solving for x, y, or x squared, x, yeah.
So is that 6.5 number 7?
Yeah, let me make sure it's 6.5.
Yeah, it's definitely not.
It's definitely not 6.5.
Ooh, nasty business.
Oh, 6.4, number 7.
That's what I said.
Yeah. Okay. Yeah, some of these in 6.4 go a little crazy. There's actually I have 3 of them that I've written ask for, but I figure if you show me one, I might be able to get the other ones.
Oh, my apologies. I'm sorry. He only wants me to find the annihilator. Oh, piece of cake. I thought it was solving a D.
Oh. It says for all problems below, use the complex valued trial solution to determine a particular solution to the given differential equation.
I'll turn my page to the correct page, the correct section. Ah. There we are. Gotcha. You guys okay with this? I mean, we're so sophisticated, there's nothing else to show anymore.
Isn't it e to the 2x?
Yeah, I think I'm wrong. I think what I have on the board would be just fine if for y double prime plus 4y, then you get the characteristic equation r squared plus 4 equals 0. That will give you complex solutions. I don't think this one's nearly that complex. No pun intended. I think directly my r values are going to be nothing more than plus or minus 2. I think my y sub c of x is going to be my c1 e to the 2x plus c2 e to the negative 2x.
Trying to throw us off that one?
Yeah, I am. I want to see where you guys are at, if you can see it that fast. So I know. And I think in a non-homogeneous case, my trial particular solution is going to look like, is that gonna be an ax plus b times e to the x times cosine of x plus cx plus b times e to the x sine of x?
Let's use an annihilator instead.
What's that?
We can use an annihilator instead.
Yes, we could.
Wouldn't that be better than?
You know, I don't know, because to me, really honestly, I just think annihilators doesn't change any of the work involved.
Use a
with it.
complex valued trial solution to determine the particular solution to a given differential
I don't want to, I
equation.
want to use this technique instead.
Okay.
Is that okay?
Well, that's
Okay,
not
that's
what
just
they asked either.
I know, but guys, I'm trying to make a point. I don't think I have anything wrong on the board. If I were to use a method of undetermined coefficient, I think that's what our trial particular solution is gonna look like. But you gotta confess, this is a lot of work. I mean, just differentiating the first term, since I've got the product of three functions, I've got multiple applications of the product rule, then I got it over there again. And then I realized, that's just y prime. I gotta do it all over again for all those terms in differentiating. I'm not saying you can't do it, you're Math 30 experts. It's just that I think there's a lot of grunt work involved. Do you guys agree? Here, without the instructions, I still would have followed the book's technique. Because without the instructions, I myself would have dove into considering a trial particular solution that's complex value. I would have suggested my z sub p is going to be, is that going to be an ax plus b times e to the
Alpha plus beta I.
1 plus,
which in this case is 1 plus I.
times x.
Now that's a lot easier to differentiate. In diving in, I will differentiate once. I know I still have to use a product rule, but you gotta confess I'm only using the product rule once in this process. And that gives me the first. Times root of the second. Plus the second times root of the first. Or shall I say, I have my ax plus a plus b times my 1 plus I times e this stuff.
I hesitate,
Yes.
because you don't have the 1 plus I term.
Wow. That's a pretty serious mistake. I hesitate too. As a matter of fact, I think I'm not even going to deal with it. I think I'll leave it as is. I think it'd be much better off instead of trying to simplify it. So I'll drop it like a rock and differentiate one more time. But here that gives me the first as is times root of the second.
Wait, I'm sorry.
Yes.
Since you have that term of x in there, shouldn't it be x squared?
You mean right here?
No, up above, right? Or am I just not getting this right?
Are you saying I should have an x squared here?
Should well, not right there, but at what you're raising the e to, wouldn't you have an x squared in there, or I might be
So you're
just
referring
way
to this
off.
over here.
Yeah.
I think this particular factor is always going to be of the form e to the alpha plus beta times x. Where alpha and beta are nothing more than the coefficients for x here and here respectively.
So how are you treating the x that's being multiplied by the 100?
By introducing a factor that's the most general
Oh,
living
okay,
factor
okay.
possible. I mean, that's how I incorporate.
No, I see it.
factor
I
x.
see it now.
Oh, excuse me, guys. By the way, I'm sorry, I was right in the middle of the differentiation process. I gotta come back. What did I just do? That was the first times the root of the second, plus the second times the root of the first. So I can give you this. Oh, yeah, Dan?
I think, for the part where you have 2 plus 2i, I think it's just 2i. If you have 1 minus 1 plus.
Oh, you're right, because this becomes a 1 plus 2i plus I squared. I had a minus I squared in my head. I'll fix it. And lastly, differentiate the very last terms. That give me a times 1 plus I times e to the. You can answer it.
2 alpha, right?
Yeah, I could, but when I wrote the first term down, I didn't see it. And picking everything up, slapping it back into the original DE. I can do that. I think I get my second derivative, which is this.
I mean, wouldn't it be better to try and clean up that second derivative?
I did it in my
first?
head.
Okay,
I combined the last two
Okay.
derivatives. And then I've got my, is it minus 4y?
Are you dropping your exponentials?
Yeah, do you mind? Because I'm just going to divide both sides by it. And minus my 4 times my z sub p, I think is going to give me this. And it's all equal to the forcing function after I divide both sides by e to the power. And I think my forcing function just becomes 100x. Here too, you yell at me if I'm skipping too much.
Yeah. No, fine, sorry.
And, shoot, where am I at, you guys? Equating coefficients of I? What am I doing?
Trying to find A, B.
See, I think if I'm trying to find a, b, and I should be equating coefficients not of I, but coefficients of x, and equating constant terms. I think that's what I need to
you
do.
need to clean things up a little bit before you can,
All right, if you want me to clean things up a little bit, does that give me this times x plus this constant plus 2a plus 2a on it minus my 4ax minus 4b.
then you should group your A's and B's together.
And equating coefficients of x, I'll group them together as best as I can. In equating coefficients for x, I see that what I have are these terms underlined here. There's the first one, and here's the second one, so only 2 of them. So does that give me a... as a coefficient of x on the left-hand side? Equaling the coefficient of a on the right-hand side. But if I equate constant terms on both sides of the equal sign, I think on the left-hand side, the constants, if I combine them, it gives me a real component of 2a minus 4b.
So what happened to your sign of x?
Oh, here it is.
Just drop?
It's right in there.
Oh, yes.
Because I think that
Because you
involves both
changed
the
it, yeah.
cosine and sine terms. Again, that's the beauty behind using this complex value solution
Yeah.
technique. Not to keep track of all the garbage. And you guys, I was mid-sentence. What did I leave off? I left off my my imaginary components of the constant term. But that would be a plus 2a plus 2b times I. And is that equal to 0? Because 0 is my constant term on the right-hand side. Well, I think in the first equation I can solve for a. Which becomes this. You guys aren't going to help me.
No.
As long as you're happy with my arithmetic. But I think that necessarily implies that when I plug that back in for a down here, I can find my b value. And let's do that. I've got 2 times a. And another 2 times a. Plus my 2b. Well, you guys, at least this is an equation only involving b, so I'll be able to solve for b. It's just going to be a complex valued number again, most likely, just like a was. So further cleanup work. You know what I need to do next, you guys? I'm worried. I can't do that fast in my head. I need to distribute that multiplication over the addition and subtraction.